In part C, we're going to be given information, and we have to come up with the equation. Okay, and all the other ones, we were given the equation in function notation, and then we had to describe it. All right. So mapping notation, given the graph, actually transform it and graph it. Now we're doing coming up with the equation. So if y equals f of x is transformed into y equals g of x, we'll write the equation for g of x in that form. So take a look at it. It's solved for g of x. So it's solved for y. It's factored inside the f. Okay? So we're not keeping it in transformation form. So some of the wording here might not be a full, proper explanation, but you can tell what transformation has been done. So in this case, I think it's good. Horizontally stretched about the y-axis by a factor of a third, reflected in the y-axis, and then translated right. So it doesn't say horizontally, but you know right is a horizontal. Okay, so if you want to do it in steps, so we're starting with y equals f of x, and you're going to have to see your comfort level. Maybe you can just go right to the answer. Okay? If we're starting, that's our base graph. If we're doing them in this order, which is the correct order, stretching, horizontally stretching about the y-axis by a factor of a third. So that will be 3x replaced with 3x. Okay. Horizontal goes with x. You show the reciprocal in there. Reflected in the y-axis, that's the vertical axis. So the x value changes sign. So the next transformation is really replacing x with negative x. Now what happens there is really that's the same as negative 3x. So I probably wouldn't show this step, right? I just put a negative in front. And whether you even show a separate step or just put it back in there. Okay. And again, it actually doesn't say to show your work. It says write the equation, which is we're only looking for the final answer. And then translated right 5, that we replace x with x minus 5 if we're going to the right. Okay. Now, take a look back. Is that in the correct form? Well, we haven't called it g of x. So the only thing different here, when you make that g of x, there's no vertical stretch, so there's nothing shown in front. This inside the brackets is factored for good, and there's no vertical translation. So you can either erase that y and make it g of x, or rewrite it with g of x. So we have to. Be vertically stretched about the line y equals 0. Okay, so y equals 0 is the x-axis, which is any vertical stretch that we do in the course is about the x-axis by a factor of 6. Reflected about the line x equals 0, that's the vertical axis, the y-axis, and then translated up 7. So again, up to you, but if I show each step, then vertically stretched, I'm replacing y by, in this case, 1/6 y. Okay, or you can go right to y equals 6 f of x. So that, because it's all the form that they wanted in, you might actually do that here. Because they want it to be g of x equals, right? Then reflected in a line x equals 0, which is the y-axis, so you're changing the sign of x. So that's going to be negative x in there. And then up 7. And again, what you're doing with that is you're replacing y with y minus 7. But we want to get y by itself, right? So we can bring the 7 over and call it g of x. Question?
Can you reflect on the x-axis while you're replacing it?
We're not. We're reflecting about the line x equals 0, which is actually the y-axis. Valeria?
Is all of this in terms of g of x or it's not?
We don't know what the function is, so. Okay, so C, vertically stretched about the x-axis by a factor of a half, reflected in the x-axis, translated left and down. Okay, y equals f of x. Vertically stretched by a factor of a half means we would replace y with 2y, okay, or, oops, that's y equals a half f of x. Right, because we have to solve for y anyway, you can just go right to this form. Then, reflected in the x-axis changes the sign of y. And this, so we would replace y with negative y. Again, just because of the form that we want to give it in at the end, might as well just do it there. If I replace y with negative y, divide both sides by negative 1, I get negative a half on the right. Okay, and then translated left 6. We'll replace x with x plus 6. And down 1, we replace y with y plus 1, which, when you solve for y, will be minus 1. And then again, we're supposed to call this new image function g of x. So it's not just y. Okay, let's look at question 7, and then we'll call it a day. Well, not an entire day. I'll call it a day for me teaching you. So 7 says the graph of y equals h of x is the graph of y equals f of x stretched horizontally by a factor of a third, reflected in the x, translated, and then it actually tells you what that original graph is. It's an absolute value function. And so we want you to write the equation of that h of x, part A in terms of f of x, and part B actually in terms of the function. So we don't care about this part for this question here. So I'm going to start with y equals f of x. I don't care that it's absolute value. It could be any function. I'm just going to follow the same steps to get my transformed function. It's been stretched horizontally by a factor of a third. So that's going to be 3x. Then it's going to be reflected in the x-axis. That changes the sign of y. So again, you can put that in right away. And then translated 1 unit left. We need brackets inside the brackets. That's going to be x plus 1. Okay, and that is called h of x.
So it's in simplified form.
Oh, right, in simplified form, so one more step here, just expand the brackets inside there. Okay. Now, what you could do for part B is take your base function, y equals absolute value of x minus 6, and do all of these steps. Or faster, since we've done this, use function notation. H of x is equal to negative times f of 3x plus 3. If we know what f is, then h of x equals negative. Put f in here, right, in this. That means everywhere there's an x here, we're going to replace it with 3x plus 3. So this is going to be absolute value, 3x plus 3 minus 6. Function notation. You guys have it a little bit easier than regular 30-2s because we did more function notation last year. 30-1s. Regular 30-.
Definitely harder than 30.
You have it easier because you did more function notation in 20-1 ID than regulars. And so, I mean, everyone will be at the same speed at the end, but you guys have a little bit of a heads up on that one. Now, we want to simplify that, right? So we don't need the big brackets because there's absolute value signs. And that'll be 3x minus 3. Okay. Now, if you wanted to start with your base graph, I'll just show it to you. So if I started with that and perform the transformations on that. So I didn't ask you part A, let's pretend. So I did tell you that on this, you want to horizontally stretch by a factor of 1/3. Then you would replace the x with 3x. Okay, so this would become, do it in green, 3x. We'd replace that. Then it says it was reflected in the x-axis, so I would replace y with negative y. Maybe I'll keep that green just so you can see it. And then I translated 1 unit left. Then I would keep, and then 3, I'll do it in red. 1 unit left would be x plus 1. You would get that, and you would simplify. So what do you end up getting? The same thing as this. You get negative y equals 3x plus 3 minus 6. Solve for y, 3x minus 3 is the absolute value signs. And calling that h of x. Okay. But because we already did the function notation, we might as well just substitute it in, right? Rather than doing it all again. So we're going to continue on. Question 8. Again, I'm going to pick and choose a few different ones. Let's do question 8. So I need quiet, please. Again, the biggest thing here for some people is just the function notation. Okay, so it says the graph of y equals p of x is the graph of y equals f of x stretched vertically, etc. Okay, so some transformations were done to f in order to get p. Then it actually tells you what f is. So that means you can actually end up graphing this. First part, express the equation of p of x in that transformation, well, in this form, which is sort of a rearranged version of the transformation form. Okay? So that means we don't need to know what the function f of x is. So I'm just going to do my work on f of x. Okay, so it says it is stretched vertically by a factor of 2. So that'd be 1/2 y equals f of x. If you want to solve for y right now, or just do that right away, you can. Remember it says write the equation. So that means you don't have to show work, okay? If it says determine, that means you show work. Okay? Oftentimes, we'll put on a test state. That's in Alberta education, we call it a directing word. It's directing you what to do, state something. IB uses the word write for the equivalent type of question. It means you're not necessarily getting any marks for your work. Okay. Then we have to reflect in the y-axis, which changes the sign of x. So if you've already done this, then that's your final answer. It's called p of x though, so I'm going to erase my y and call that p of x, or rewrite it with p of x. Okay. This is like one that we did yesterday. You can then go do the same steps through f of x to get your transformed function in terms of x. Or if you've done this, use function notation. So p of x then equals 2 times whatever f of negative x is. Here's f of x, so I'm just going to put negative x in for every x, and then simplify that. So that's going to be negative 2x over 1 plus x, which you could, p of x equals negative 2x over x plus 1. I'm going to leave question 9 because the transformations have already been done. So you just simply have to do like this, use your function notation. So I'm going to leave question 9 for you to do. Okay, take a look at 10. Look at the graphs.
Oh, is that right? If you multiply both the top and bottom by -1, you get 2x over x plus 1.
You're not multiplying by this.
No. It's the two forms we're trying to. Oh, never mind. Sorry. Yeah, sorry. Oh, I was thinking of the other.
I just put it in descending order. Okay, so you're going to do this. I'll come back to it at the end. I'll put it in the video for you. Okay. And question 10. So we are given two functions here. H of x is the transformed image of f of x. Sometimes it's hard to tell which point is transformed to which, but there's a good labeling here. So you know that this point here is the image of this point, right? A and A prime, C and C prime, okay? So that helps. If they're kind of close to being like a V shape or something like that, it's a little bit hard to tell if it would be a reflection or not. This, now, by looking at that, I know there's going to need to be reflected, okay, about the y-axis. Because they both have a V shape of some form, so they both open up, so there's no reflection in the x-axis. First, start with the stretches. So notice how we don't have to write out in words what happened. We have to write it in terms of f of x, and then simplify, right? So make sure it's in that simplified transformation form. So here, what I want to do, here's my F. I want to look for my stretches. So how wide is that? That's 4 units. How wide is this? 4 units. So I know there's no horizontal stretch. Vertically, the height is 3 units. Here, the height is 9 units. Okay, that tells me, and again, it's not asking for this, but I'm going to just use short form to remind myself. It's been vertically stretched by a factor of 9, factor of 3. That's how we get 9 for the height. Okay, and then I do know there's been a reflection around the y-axis because that left point is now the right point. So reflection in the y-axis. Okay, now I'm going to actually sketch a graph using those two transformations. So then I can get my translations easily. So this point here, if I vertically stretch by 3, it's on the x-axis, so it stays there. And then I'm going to reflect in the y-axis, so that's -5 is going to become +5. So that's sort of your intermediate A. I'll call it double prime. B here, vertically stretched by 3, so y value 2 becomes 6. And then reflect in the y-axis is here. Okay, so that's kind of like, I'll call it B double prime. Do you need to do much more? Not really. Okay, because there's your arm, right? You can do the next part, but I could have stopped here, really. I need to make this move to here. The only reason why I do 2, say that I forgot a reflection or something like that, then if I only do 1 point, I may not touch it, right? So, in this case, gotta go up 1 to the right 1, okay? Up 1 to the right 1. So then, vertical translation up 1, horizontal translation right. Okay. So, starting with y equals f of x. Okay, vertically stretched by 3 would be 1/3. If you want to put it in right away, actually, what does it say here? Yeah, so in simplified form, you have to solve for y, right? So you can do that. Reflect in the y-axis changes the sign of x. Vertical translation up 1. We can replace y with y minus 1. But we know that that's the same as y equals 3f of -x plus 1. You do not have to write all these steps. I'm just speaking and writing them up, right? There's no work in this. Okay. And then right 1 would be replace x with x minus 1. So you may have got this right away. Technically, it's not quite in simplified form, right? It's solved for y, which is good, but I need to expand in the brackets. So that would be the form. B and C, I'm going to leave those for you to do. We already did one that has an open circle. That's like in C. So you can refer back to, I think that was in part A. I'm going to look at question 11. 11 has mapping notation. And we've done mapping notation, but we haven't really gone from mapping notation to put it into the equation of a function. Okay? Okay, so I'm going to leave those for you to do. I'll go back and do them for the video. We're going to do question 11. Okay, so it says the function y equals f of x is transformed such that the point xy corresponds to that point. Negative x plus 1, 3y minus 2 in the transformed graph. Write the equation of the transformed function in that form. So it's not really in, notice, it's not really in a form that has a name, right? Because if it was in transformation form, that a would be 1 over a on the left. Okay, so it's in a slightly different form. In any case, we have to look at the mapping notation and figure out what was done. So remember, mapping notation is what happens. So with the x, we have obviously a reflection. If we're changing the sign of x, it's in the y-axis. We have going right 1, okay, translation right 1. Here we have a vertical stretch by 3, and then down 2, okay. It doesn't say to write out the transformations individually, but I'm going to, just briefly. Okay, I'm not putting all the words. So when I do that, on my y equals f of x, I'm going to have y equals, well, I could replace it. I could have 1/3 y equals f of x, the number, so that's y equals 3 f of x. Because it is asking for that a value to be on the right. Then I would state reflections. In this case, we're changing the sign of x, so that's in the y-axis. So we're changing the sign of x. Okay, then translations. So I can do the horizontal. So horizontal, we're adding 1 there, which means we're going right on the axis, right on the number line. Right 1. Okay. So remember, mapping notation is what is happening. When I put that back into my equation, though, I want to put brackets around x and put x minus 1. Okay. Notice how the final form we're asked for is in factored form, so I'm not going to expand out those inside brackets. Okay. And then I'm going vertical translation down 2. So I could replace y with y plus 2. And that's what I have to do, right? Because it's not asking for it to be solved for y. Okay. So that's final answer. So you do not have to do all those steps. You can go right to that, but that's you might want to do, at least for some of them, before you're practicing, right? Okay, so the next one is very similar. And you're going to do that one on your own. And then look at 13 on the right-hand side. So it says the graph of y equals f of x shown below is transformed into y equals h of x using 2 stretches and 2 translations only. So that means not 3, not 1, or 0, okay? And stretches and translations, so no reflections, okay? Domain and range of h of x is given to you now, so you're going from 0 to 5, negative 10 to 8. Describe in the correct order the transformations that took place. So what I want to look for here is you can look at the actual x and x values and y values. I always kind of start with how wide is the domain, right? Well, it's from -6 to 4, so that's 10. How high is the function? -4 to 2, so that's 6. In interval notation, right, the width of the graph, because the first one is domain, so this is domain, this is range. The width here is 5, okay? Well, this is 10, so it's going from a width of 10 to a width of 5, right? This is your image. So that means a horizontal stretch by half, okay? So, horizontal. Then the height is 6 units. This is 18. So we're starting with a height of 6 and we're ending with a height of 18. That's vertically stretched by a factor of 3 then. Okay, so let's think about, because we have the graph, let's do that and see how that compares to the domain that we need. So leftmost point, horizontal stretch by a factor of a half, so -6 becomes -3. And then the y value is stretched by 3, so 2 becomes 6. Then here, x is -2 by half is -1. Stretched vertically, now that's going to be at -12. It's off the charts, as they say. Okay? But that's going to be, I'll just do a quick sketch. Okay, this would be a half, and then down here, okay, same point is going to be horizontal to it, half is wide. Then this point, horizontal stretch, that's going to be 2, and then -2 times 3 is -6. Okay, so the stretches are going to get us something like that. If you want to graph it, because the graph is given to you, you might as well, you might find it easier. You don't have to graph it. What does that do to this domain, right? Because our original domain was from -6 to 4. So the original, -6 to 4. Original range was -4 to 2. Okay. So now, our new domain, well, half of -6 is -3. Half of 4 is 2. So now we're going from -3 to 2, horizontally. All right? We need to get to this. So you might want to do it in steps. So this here will give a domain of -3 to 2. And we want to have a domain, final domain of 0 to 5. Oh, actually, not to the vertical there, because let me erase this part. This will be for this. Okay. So this is domain, right? So then, how do I get from this to this? I got to move that graph 3 to the right. So this will be a horizontal translation. Oh, I guess I don't use full words. This is after stretching, and I gotta end up at 0, so I'm gonna go through it.
Oh, oh,
That's your image domain. Right? So then, so now our range here, actually I have it there, range is -4, 2. After that stretch. Okay. Oh no, what did I just do? Right here, this is negative, oh, that's the original, right, -4, this is the original. Okay, so the original was -4 to 2. This intermediate is now from -12 to 6. Okay, so then this is going to be, after this, -12 to 6. And we need it to be from -10 to 8. So 6 up to 8 is add 2, -12 plus 2 is -10. So we need a vertical translation of 2 up. So you have all of those descriptions written out. Now write the equation of h of x in a simplified form. Okay, you can go through the steps, or you can put it in right away. So if I put it in right away, vertical stretch by a factor of 3. Horizontal stretch by a factor of 1/2 will be 2 here. Bracket, horizontal translation, 3 right. Outside the brackets, up 2. Okay. Simplified forms, you solve for y, but then in the brackets, you expand those brackets. Okay, lots of talking, so that means you're done. Okay, so we're going to, basically now we finished part C. You have to do a few on your own. They'll be in the video if you want to watch it. Or they're on the answer keys. Part D, putting everything together. Actually, question 14 is very similar, listen you guys, to the last question, except the graph wasn't given to you. So just, well actually, it's a bit easier than the last question because the domain and range of the original are given to you. And you need to find the domain and range of the transformed graph. So I'm going to leave that one, and then we're going to do 15. Okay. This one actually gives you the coordinates of a point on the original, and it says determine the image of that after the transformation. Okay. So you want to look here, make sure that this is in factored form, because right now it's not. Okay? And then think about what transformations were done. So there's a vertical stretch by, oh no, there's no vertical stretch, sorry. There's a horizontal stretch by 4, reflection in the x-axis, right there, and then translation. Horizontal translation to left, vertical translation 5 up. Now do those transformations on the point, oh, this is not, this is 60.
Yeah.
Sorry. Okay, this is question 60. We'll go back to 15. I must have missed it. I don't know. So we're doing 60.
60?
16. 1 6. Right there.
My hearing is like severely damaged.
Well, we're
It is, that is the exact reason.
Don't you work those?
Yeah, I do, but it's still extremely loud.
That better one?
Just, it's not facial, that's what. Anyway, math time.
Okay, so this is general point XY. If you want to show it step by step, you can, or you can go right to the final answer. If you do it step by step, horizontal stretch by 4, reflect in the x-axis, horizontal translation to left, vertical translation 5 up. Okay. Actually was kind of similar to this one. Okay, let's look at question 17. Students get a little bit mixed up with this one. Nothing different from what we were doing, except our f of x happens to be a polynomial function that's in factored form. So students get kind of like, don't, I don't know, freaked out or whatever. Doesn't matter, we just did one that was irrational. We've done one that's an absolute value. Just because there's brackets in the original function doesn't make it any harder. You just have to deal with more brackets. So let's do this one. We will do more of this when we at the last, transformations of polynomial functions on the last day of this unit. Because that's a polynomial, right? It's a quadratic. In any case, it says the graph of y equals f of x is stretched horizontally, reflected, translated into the graph y equals capital T of x. It's just the name for it. So write that equation in terms of f of x with T of x isolated. That means with y isolated. So here, y equals f of x is what I'm starting with. I'm horizontally stretching by a factor of a half. That's going to be 2x. Reflected about the x-axis changes the sign of y. You can just put it in there right away. You could solve then if you wanted to. Up to you, right? Then, because you do have to solve for y, if you like. Translated 3 units right. So replace x with x minus 3 in those brackets. And 1 unit down, I would just do that there. I mean, yes, you could replace with y plus 1, but pretty easy to just do that at the end. It says write the equation of y equals t of x in terms of f of x, okay, with t of x isolated. That's all that they're asking. This is your t of x. This is your new function. Instead of calling it y, we're calling it t of x. It doesn't say whether you have to simplify the brackets or not, it doesn't say simplify, so I'll just leave it like that. Saying that, when you look at the next part of the question, it says if f of x equals x times x plus 4, then write the equation of y equals 2x in terms of x. So that means I now can use this function notation. We've done this a number of times already. Use this and substitute in here. Okay, use your knowledge of function notation. Or you can take this and do all of those transformations on this function within it.
Alright, and why would you do that?
Not sure.
Okay.
Okay? So, but there is more than one way in case you don't like function notation. But if you're in Math 30-1, you can't not like function notation because you can't get away from it. Now, what you might want to do here is I would probably expand the inside of the brackets there. Okay? Because you're substituting this in for every x. So if you've got two brackets, it's going to get brackets, right? So I would do that. I'll copy out the negative. Basically, it's like you're copying everything else except for that f. Okay? Instead of f of 2x minus 6 now, we know what that f is. We're going to replace every x, so there, and there, and there, with 2x minus 6. So this is going to be, maybe I'll get that green. That, and then another bracket, and this bracket. So that's where students get like freaked out with so many brackets. There's your x is now that first bracket, 2x minus 6. Open bracket. This x is this 2x minus 6 plus 4. Now, what's another thing that you could do back here, maybe to eliminate some brackets? Open it. What does open mean?
Open
Open the door.
Open the bracket.
What operation is that?
Multiplying.
Expanding, sometimes we use, or distributive property. Yeah. So you could go, okay, f of x equals x squared plus 4x.
That's what I learned from it.
And then you're putting those brackets in there, right? And expanding that out. Okay? So, you might find that easier. If we do this, I'm going to show just this bracket. I'm going to simplify that. That's 2x minus 2. And then here, expand that out. This is where good attention to detail helps you out, right? So I've run out of space a little bit here. I'm just going to write it. Okay. Now, let me just check and make sure I got the same thing. I did it this way. Then I would have 2 of x equal negative. And then I have 3x minus 6 squared plus 4 minus 2 plus 6. And then this 1. Okay, get the same thing, so it doesn't matter, right? I just want to, actually, when I ended up doing it here, then numbers wise, these are bigger numbers. So you keep it in factor form, you're doing the smaller numbers. Hopefully you know your times tables. Okay, so then on the right-hand side, continuing with this, it says algebraically verify that the point negative 612 lies on the graph y equals f of x. That's your original graph, okay? So, how I like to verify, okay? Every teacher is a little bit different, but we're all common in the fact that you have to keep the left side separate from the right side. So no equal sign in between. So here, I've got f of x, I'm just copying it out here. So what I like to do is that I would call it a T chart. I make a T, okay? Left side is your f of x, that's your y value. So in this case, you can call it left side, you can copy that out, whatever you want. In this case, it's 12. On the right side is this. So what do I get? I need to substitute negative 6 in for x. Then I put an equal sign on the right of that. Okay, you can even put one here because that's what they're equal to. But you're not, without that line there, you're saying that they are equal. You're trying to verify if they are equal. So you don't want to say that they are until you know. Okay. So negative 6 there, this will be negative 2. So that's going to give me positive 12. So the left side equals the right side. Okay. You can simply just write left side equals 12, right side equals negative 6 times blah, 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 and then left side equals right side. You don't have to do two terms. But this is what I don't want to see. With brackets or whatever. I don't want to see that. Because we don't know if it is, right? So,
Is there a symbol for maybe, might be equal to, could be equal to?
not that I know.
I
Approximately.
have a question. At the top, can we write assume that they are equal, and then if they're not, you'd say they're not?
No.
So you can't even write assume that they're equal?
Well, I mean, most times they are going to be equal, but algebraically verifying means you need to check by putting it back in, right? If it didn't ask for algebraically verified, then you could use your calculator.
Graphically verify.
Yeah, graphically verify.
Or just verify.
Yeah, so we, right, substitute back in. Okay, so then D, it says determine the image point negative 612, the image of that point. Because that's the only original. So we have to go through, I'm just going to put this on 2 page here, it's just that. Okay, so I'm going to go through the transformations on this point. So negative 612. Then horizontally stretching by half would be negative 312. Then reflecting about the x-axis would make that y value change side. And then 3 units right would get me to 0. And 1 unit down, negative 13. Now verify that. So now we're going to check that point in our T of x. And this, I mean, hopefully you can tell right away, right? The x value is 0, the y value is the constant. But algebraically verified. Left side is 2x, that's negative 13. Right side is negative 4 times 0 squared, equals 16 times 0 is 15. Okay, and then the graph of the original is shown there. Use your transformation skills to graph the sketch the graph of the t of x. Using your transformation skills, and then verify that. So basically, you have the equation of t of x, graph it in your calculator, and see if you got the same thing on your graph paper. Okay, so vertex, we are horizontally stretching by half, so the x value of negative 2 becomes negative 1. Then we are reflecting about the x-axis, so that negative 4 becomes positive 4. And then we are translating 3 right. And then we are going 1 down. Oh, look at that. Okay. That's the vertex. Okay, you know that it's going to be opening down because there's a reflection in the x-axis. Choose another nice point that looks like this point here. Looks good. Negative 4, 0. So, negative 4 horizontally stretched by a half will be at negative 2. Translated in the reflected in the x-axis doesn't change it. Then 3 right and 1 down.
If you can choose the origin as your point, do that.
Yeah, and then this one, the origin, can transform the same way. Remember, this is a parabola, guys. So this is a parabola, it's going to be symmetrical. So if you did the right, that 0, 0, it would get you there, and you know it's symmetrical about that vertical line. Okay, so it looks something like that.
What is QED?
Means you're going to done. I forget the degree statement when you do a mathematical proof. Okay, so verify your graph on your calculator. Okay, so what did we say it was? I have to go left here. We said it was negative 4 x squared plus 16x, so negative 4 x squared plus 16x minus 13. You're on a standard screen. Obviously, the scale is going to be a little bit different. Check it out. So trace, we think the vertex is 2, 3. 2, 3 is the vertex. We think that it goes through the point 3, negative 1. Trace 3, negative 1. So you can check some points. Okay. Okay, we're going back to finish up the ones that we didn't get done in class. So f of x equals 3x squared, g of x transformed of it. Write the equation for g of x in simplified form. So because we already have that transformation, just use your function notation. All right, so 1/3, and then you're replacing every x in f with negative x plus 1. So that's going to be 3 negative x plus 1 squared. And it's in simplified form, so we're going to expand out. Notice here 1/3 times 3 goes to 1. So that's just going to be x squared minus 2x plus 1. The next one that we did not do was these graphing ones. So we are finding, I don't think there's any restrictions in this. Yeah, just all the transformations, any transformations. So we're going from F to H. So I always look at the domain, it's 3 wide. Domain here is 9. So that means there's a horizontal stretch by 3. Vertically, it is 3. This is 1.5 or 1.5. So that means we are doing a vertical stretch by half. So let's do that on the first original graph. So horizontal stretch by 3, 2 times 3 is 6. Vertical stretch by half will be here. 3 times 3 is 9. It's off the grid. Okay. 5 times a half is 2.5. Then this 5 times 3 is 15. Okay, and then staying vertical height, so this would be 15, comma 2.5, just to have that. Okay, notice how there's got to be a reflection then, right? Because that this diagonal part is now opening the other way, so we'll reflect in the y-axis. So that 6 will then become negative 6, and that would become 9 here, so like this, and across. And then we're moving all of that. So this point here has to go down and all the way here. So what is that down? 1, 2, 3, 4.5. And this is to the right, negative 6, positive 6, so that's 12. Okay, and we don't like using decimals, so start with that. Vertical stretch by half will be half, and then f of 1/3 x. Then horizontal, we went right 12. And vertical, we went down 4.5, which is 9/2. Okay. These look like parabolas. There's an open circle, so we just have to be aware of that. We're starting at F here. This is 2 wide. This is still 2 wide. So there's no horizontal stretches. This is 8 high. This is 4. So that will be a vertical stretch by half. Okay, so let's do that. Also, we know there's going to be a reflection in the x-axis, actually, because of the direction of opening. So let's do those two. So this point, vertically stretched by half, will be at -3. Reflecting the x-axis will be +3. Vertex, vertical stretch by half is 1. Reflecting the x-axis is -1. This will be -3, +3. Okay, and now we want to translate. So what are we doing? Up and over. So we're up 1, 3/5. Okay, so vertical translation up 1, horizontal translation left 5. So y equals, that will be half f of x. Reflecting the x-axis, we change that to negative. Then translations, left 5 and up 1. Okay. We did 11. Let's do 12. It says the graph of f of x is transformed according to that mapping notation and show it in transformation form. Okay, so what's happened here? Look for the stretches. So horizontal stretch by 4. It's not asking you for the formal description, so I'm just using the short form. Vertical stretch by a half. reflection in, so you're changing the sign of y, which reflection in the x-axis. Then you're doing, you can do a horizontal translation. That would be, you're subtracting 5, so that's left 5. And vertical translation, up 3. Okay, so it says in transformation form, so that means we're not solving for y. So when we do our stretches, that's going to be 2y equals f of 1/4 x. Reflect in the x-axis, changes the sign of y. And then we're going up 3, so y minus 3. And you're going left 5, so x plus 5. Okay. (13, 14) says if the domain and range are given, okay. Notice how they didn't put in x element of 7 reals because, but we should have, okay. This was from a couple years ago. Then determine the domain and range of g of x after all those transformations. So I'm going to write out the transformations. So vertical stretch by 1/2, horizontal stretch, fix that, horizontal stretch by 3, reflection in, so y is changing sign, so in the x-axis, and then vertical translation 5 up, horizontal translation 1 right. Okay, so domain is only going to be affected by things that are horizontal, range with vertical. So if we take a look at the domain, and this is a horizontal, and this is, okay? So going from -3 to +1, that's 4 units wide. I just do that to check if there are boundaries. If I'm doing a horizontal stretch by 3, then that's going to end up being -9 to +3. Okay, I'm not going to do the whole form, I'm just getting that. So now that's 12 units wide, which makes sense, horizontally stretching by 3. Then to the right one, a -9 will become -8. 3 becomes 4. Okay, so that's going to be your domain of your final. Your range is just got one boundary, so it goes to -infinity. We're vertically stretching by 1/2. That's going to end up being y less than or equal to 1. 2 times 1/2 is 1. If we're reflecting in the x-axis, everything now that's less than or equal to 1 is going to be greater than or equal to 1. Okay, so we've reflected it. And then we're going up 5. So that's going to be y greater than or equal to 1 plus 5 is 6. And that's your range. Okay, so that's your range. This is your domain. And then again, check. Yeah, so we already checked that's 12 wide, and that was 4. Okay. Question 15, -3, 8 lies on the graph of the original. Determine the image after those transformations. Biggest thing, make sure you factor. The x, that's already been factored, so that's good, but the y wasn't. Okay, so what's happening here is a vertical stretch by 1/2. Reflection, x is changing sign, so reflection in the y-axis. Vertical translation down 3, horizontal translation 1 right. Okay, so starting with -3, 8, vertical stretch by 1/2. It's going to be 4. Reflect in the y-axis, changes the sign of x. down 3. 4 minus 3 is 1. Right 1, 3 plus 1 is 4. And I think we are just checking here and make sure we finished it all, and we